By the end of today's video, the mole concept will become so clear that instead of saying, "Give me 1 kilogram of potatoes," you'll feel like saying, "Give me 1 mole of potatoes." In this video, we'll learn what a mole actually is, the formula used to calculate moles, how many particles are present in 1 mole, and we'll practice different types of questions together. So, hello everyone, welcome to LearnXverse. Before we understand the mole concept, we first need to learn how to calculate molar mass. To find molar mass, you first need to know the atomic masses of the elements. If you don't remember the atomic masses, don't worry. You can simply look at the periodic table shown on the right side. Now let's solve a question. Find the molar mass of methane, CH4. Methane contains 1 carbon atom, 4 hydrogen atoms. The atomic mass of carbon is 12, and the atomic mass of hydrogen is 1. Since hydrogen appears 4 times, multiply its atomic mass by 4. Now, add the masses together. 12 plus 4 equals 16. So, the molar mass of methane is 16 grams per mole. The unit of molar mass is generally written as grams per mole. Find the molar mass of C6, H12O6. Carbon has an atomic mass of 12, and there are 6 carbon atoms. So, multiply. 12 times 6 equals 72. Hydrogen has an atomic mass of 1, and there are 12 hydrogen atoms. So, 1 times 12 equals 12. Oxygen has an atomic mass of 16, and there are 6 oxygen atoms. So, 16 times 6 equals 96. Now add all the atomic masses together. 72 plus 12 plus 96 equals 180. So, the molar mass is 180 grams per mole. Before moving ahead, let's solve one last question so our concept becomes even stronger. Find the molar mass of carbon dioxide, CO2. Carbon has an atomic mass of 12, and carbon is present 1 time. 12 times 1 equals 12. Oxygen has an atomic mass of 16, and oxygen is present 2 times. 16 times 2 equals 32. Now add the atomic masses together. 12 plus 32 equals 44. So, the molar mass of carbon dioxide is 44 grams per mole. Let's start with the heading, what is a mole? A mole is the amount of substance that contains 6.022 times 10 raised to the power 23 particles. That means a mole is an amount that contains this many particles. For example, 1 dozen eggs means it consists of 12 eggs. Similarly, 1 mole contains this many particles. Mole is just a unit. Just like kilogram is a unit for mass and liter is a unit for volume, mole is a unit used to count particles. This number is called Avogadro's number. And this number was discovered by Amedeo Avogadro, which is why it is called Avogadro's number. Alright, now it's time to practice some questions so this concept becomes crystal clear. The question is, how many moles are present in 17 grams of ammonia? In this question, we need to find the number of moles. The formula to find moles is given mass divided by molar mass. Here, the given mass is 17 grams. Now let's find the molar mass of ammonia. Nitrogen has an atomic mass of 14. Hydrogen has an atomic mass of 1, and hydrogen is present 3 times. Add the atomic masses. We get 17 grams per mole. Now find the number of moles. Moles equals 17 over 17 equals 1 mole. If we slightly modify the question and ask, find the number of molecules present in 17 grams of ammonia, then instead of finding moles, we need to find the number of molecules. As we already know, 1 mole equals 6.022 into 10 to the power of 23 molecules. And from the previous question, we found that 17 grams of ammonia is equal to 1 mole. So, simply multiply. 1 times Avogadro number, which is further equal to Avogadro number. Find the number of moles in 2.5 kilograms of ammonia. We are given the mass as 2.5 kilograms. First, we need to convert it into grams because molar mass is usually expressed in grams. We multiply 2.5 by 1,000 and it becomes 2,500 grams. Now let's calculate the molar mass of ammonia. Nitrogen has a molar mass of 14, and hydrogen has a molar mass of 1. Since there are 3 hydrogen atoms, we multiply by 3. We get 17 grams per mole. The formula for finding moles is given mass divided by molar mass. Our given mass is 2,500 grams, and the molar mass is 17 grams per mole. If we divide them, it comes out to approximately 147 moles. So the number of moles in 2.5 kilograms of NH3 is approximately 147 moles. In 4 moles of ethane, calculate the following. 1. Number of moles of carbon atoms. 2. Number of moles of hydrogen atoms. 3. Number of molecules of ethane. In this question, they are asking for 3 things. Number of moles of carbon atoms, number of moles of hydrogen atoms, total number of ethane molecules. As we can see in the question, we are given 4 moles of the compound. To find the moles of carbon atoms, we look at the formula of ethane, C2H6. There are 2 carbon atoms in 1 molecule, so we multiply 4 by 2. So moles of carbon atoms equals 8 moles. Similarly, there are 6 hydrogen atoms in ethane. So for hydrogen, 4 times a 6 equals 24. So moles of hydrogen atoms equals 24 moles. Now for the last part, asked for number of molecules. We know that 1 mole equals Avogadro's number of molecules. So in 4 moles, it will be 4 times Avogadro's number, which is equal to 2.4. Thank you everyone for watching. Calculate the total number of atoms present in 11 grams of CO2. And this concept to solve this question, there is a twist. Easy for you. First, see you in the next video. We will find moles, then multiply by Avogadro's number, but that is not enough because the question is asking for atoms, not molecules. So we will first find the total number of atoms and then proceed. Let's start by finding moles. The formula for moles is given mass divided by molar mass. Given mass is 11 grams, and molar mass of carbon dioxide is 44 grams. After divide, we get 0.25 moles. Now we will find the number of molecules. We multiply 0.25 by Avogadro's number. The result is 1.505 times 10 to the power 23 molecules. Now we find the total number of atoms. In CO2, there is 1 carbon atom and 2 oxygen atoms, so total equals 3 atoms. So we multiply 3 by 1.505 times 10 to the power 23. We get 4.515 times 10 to the power 23. Number of atoms.